A very warm welcome to each and every one of you in line. It's 1:01 Central Europe time, and we warmly welcome you to our web series. So our web seminars that takes place due to the fact that the Interpack this year does not take place. Very sad. And we at BASF thought, hey, it's a cool idea to show you virtually our products and our cool projects we wanted to show you actually at the Interpack this year. So, but it's our last webinar for today. So we had 2 amazing weeks behind us. And so it's a pleasure to have an amazing topic at the end, which I would like to introduce to you today. So we will talk about our Pharmaboxes made from Styropor CcycledTM and how they go around the world. And we have 3 experts with us today. Thanks again for joining today. And you can see them already in the cameras and now also on the screens. So we have Alexander Doskutil from HIRSCH Porozell, who is a business development manager. And we have Sven Rölle from eutecma. He's a sales manager there. And we have also Jesus Corral from BASF, and he's our marketing manager for the styrenics business in Europe. We have one Q&A responsible also for you today. So we have Sven Heppes. And if you have any questions, please direct them to Sven. You can do that via the chat or the Q&A function. I will come to that in a minute. And my name is Nina Osten. I'm in the communications department in the monomers division at BASF and responsible for the polyamides communications. So also very warm welcome from all our side. And before we go into the content, I would like to share some Webex housekeeping rules with you so that you know what is going to happen today technically. And if you have any technical issues, you can contact me directly via the chat. So please feel free to reach out to me when you have any issues. So please provide your full name when you dial in. Do not appear as a dial-in user. We have put you all per default on mute. And you can ask your questions, as mentioned already, via the chat functionality or the Q&A function on the right-hand side of your Webex tool. Or you can also raise your hand virtually so we can unmute you and you can ask our experts directly. So all questions will be answered after the session. So if you have seen the presentation from our 3 experts, and we would like to ask you, please turn off your video. Our speakers will for sure have their video turned on that you can see them all the time. But for the rest of you, due to bandwidth issues, please turn it off. We recommend you to use the voice over IP audio connection, so the call using computer function. And please be aware we will record the session today. We will publish it afterwards on our website where you have already registered, so that those participants who are not able to join today can watch the video later. In general, please don't be afraid. You're not alone in this webinar. You only can see yourself. That's why I'm saying that. We have around about 35 participants in line, so that you know you are not alone. You have some more people here. We do that due to data protection reasons. And with that, I hand over the ball to Julia, who is also in line with us, also from the communications department from petrochemicals, and she will share the slide with you. So Julia, the ball is yours.
All right.
Yes. Yeah, thank you very much, Nina, for this kind, warm welcome. Yeah, as you already said, we have 3 speakers here now at our webinar today, who will represent each one step of the styrenics value chain, let's say. We have Jesus Ocaña from BASF, who represents the raw material perspective. Alexander Doskutil, the converter perspective, where the beads and the styropor granulates are foamed into boxes. And finally, the sales perspective from Sven Rölle and eutecma, the company who sells the Pharmaboxes. So I would like to ask a couple of questions straight ahead. The first one goes to Sven. Our headline is Pharmaboxes go around the world. So could you please elaborate a little bit more what the Pharmaboxes are about, what they are used for, and why eutecma decided to go for Styropor CcycledTM?
Okay, that's quite a lot of questions right to the beginning. But yeah, we have specialized in pharmaceutical packaging with regards to the pharmaceutical companies, and therefore we have launched our Protect shipping systems, and this is a complete portfolio of qualified coaching shipping systems, starting with the smallest solution with a payload volume of about 4 liters, and going up to the biggest one with a payload volume, it's called the X-Large Pallet Shipper, and a payload volume of about 1,600 liters. And all the boxes have durations, can fulfill a duration for up to 120 hours in certain temperature ranges. In the pharmaceutical industry, we're always talking about different temperature ranges. Therefore, we have a temperature range of cool. It's a temperature of 2 to 8 degrees. Then we have a temperature range of ambient with a temperature spectrum of 15 to 25 plus, and as well the frozen conditions with temperature requirements below -20°C. And due to the actual situation, the brand new temperature range, which is below -70°C. Each project system covers all the temperature ranges, and from my perspective, this is really wonderful because as we can see in real life, and it's currently shown with the various COVID-19 vaccines that needs to be shipped, stored, and at different temperature ranges. Therefore, for example, our boxes are used to ship the AstraZeneca vaccine at the temperature range of 2 to 8. As well as the Moderna vaccine in the temperature range of -25 to -15°C. And this all can be done in just one type of packaging, just by adding the appropriate cooling elements inside the shippers. I guess what is necessary for you to know, we're talking here about passive solutions. So they are all been iced with special cooling elements.
Very good, very interesting, and a topic of a very newsworthy topic, let's say, yeah, because the vaccine shipping is now, so everyone is quite familiar with that. So thanks for sharing that. But one more question in regards to the use of Styropor CcycledTM specifically. Why did you and why did eutecma decided to go for Styropor CcycledTM packaging?
So it's just a few words in regards to Styropor. So it's when we are talking about pharmaceutical packaging, we are in an area with strictly quality requirements that the pharmaceutical packaging have to fulfill in regards to GDP, which is a good distribution practice. And in our opinion, for the moment, there is no better material available to handle these types of packaging than Styropor for the moment. And here again, I can switch on the current examples around the COVID-19 vaccines, because it shows that the majority of that shipments is done with boxes made of Styropor or neopor right now. And this is because this is really a good material with a proven and available material with great properties. But the goal why we decided to go further with Styropor CcycledTM was also because we are aware of our responsibility. We are constantly searching for more sustainable solutions. And for this reason, we were very pleased that contact was made to BASF through HIRSCH Porozell. And the very biggest advantage, from my perspective, to continue the way with Styropor CcycledTM is that the performance of of that material is absolutely equal to the performance that boxes molded in virgin materials have. And for this reason, as I said, in that pharmaceutical world, we are always in every box has to be approved and every box has to be qualified, which is quite a lot of work until you have a box ready to use. And therefore, this is for me the biggest advantage, because there is no re-qualifications necessary, because the thermal performance is absolutely equal to boxes made of virgin EPS. And so, of course, there are no excuses for not using that material.
Very good, yeah. Just very interesting, Sven, just handing over and explaining a little bit more what, the advantages of products coming from chemical recycling are. So, Jesus, could you elaborate a little bit more on the raw material perspective and explain a little bit for our attendees what the ChemCycling project is all about, and how it's used in the styrenics business.
Okay, yeah, sure. Well, I think that before explaining in more details how the ChemCycling approach at BASF works, I would like to give or to put you a little bit more on context, about the motivation of BASF to start with such a project. First of all, it's clear that for BASF, one of the most ambitious targets of BASF in terms of sustainability is just to drive circular economy. That means that one of the main aims for BASF is just to keep the limited resources that our planet has in use. For that reason, BASF decided to develop a circular economy roadmap, and this roadmap is based in 3 different pillars. First of all, we want to create new business models. We want to develop new material cycles, and last but not least, we want to work with new feedstocks. If we put the focus on this, BASF is working in 2 different approaches. The first one is the biomass balance approach, where BASF can use renewable feedstocks at the very beginning of the value chain, and in this way we can offer our customers products with a better carbon footprint. Then the second approach of BASF is the ChemCycling approach. In this case, the goal of BASF is just to produce products like Styropor CcycledTM from chemically recycled plastic waste. But okay, how does it work? In principle, our opinion is that we need to avoid the typical linear economy used in the past, where the typical end of life of plastics was landfill, because as all of you know, if the end of life landfill triggers with a higher probability to the plastic littering. Our opinion is that there are better alternatives to the use of plastic waste for recovery. You have to use this feedstock for energy generation. Therefore, the focus of BASF is to create a contribution to the circularity of plastics, either via mechanical recycling or via chemical recycling. Then let's put the focus on ChemCycling, because this is the topic of today. And as you can see here in the right-hand side of this slide, mainly the approach consists on that after the end use from the side of the consumer, the plastic packaging or the plastic in general, this plastic is disposed in the plastic bins. No? Then the waste companies are collecting this waste and they are sorting out. No? They are sorting out in materials which can be recycled, materials which have established recycle way, but there is still a fraction of this plastic waste which is not recycled. No, this is not technically feasible, and it is sent to incineration. This fraction of the plastic waste is the target of the pyrolysis oil plants. No, we are working with different suppliers. And the target of these suppliers is just to use this fraction, which can be difficult to recycle due to several reasons. For example, in the case of multi-layer packaging, it is difficult to separate the different materials. It can be that there are packaging highly contaminated by food, for example, or even there is a fraction of plastic packaging which is not sorted out due to economical reasons. It can also be old tires, which normally they are disposed in landfill. This fraction, this part of the plastic waste is the target of our suppliers, and they are transforming this plastic waste into a pyrolysis oil. No? They are using a thermochemical process. What they are basically doing is just to break down the plastic, the polymer chain into smaller building blocks, no? Into smaller molecules. No? And then after a purification process, BASF can use this pyrolysis oil as an alternative feedstock to our main raw material in our Verbund, the naphtha. As you know, or most of you know, the Verbund in Ludwigshafen is a big interconnected production plant where many production plants are linked each other. Therefore, it is not possible just to use this part of the pyrolysis oil only for one value chain. And what BASF is doing is just to mix this plastic waste, this pyrolysis oil made of plastic waste with fossil resources, and we are allocating this pyrolysis oil to the final product. No? This is a mass balance approach. We are working with a specific standard, with a certification scheme, Red Cert 2, and we are yearly audited by a third party to make this approach as transparent, more transparent as possible. Then this is basically one of the main BASF contributions to the circular economy. No, I think that we need a big problem or a big challenge, global challenge for plastics, and this is the BASF contribution just to reduce the quantity of plastic waste. No? Of course, this is one of the main advantage. No, we are processing, we are producing this pyrolysis oil from recycled plastic waste, and by using this, we are also saving fossil resources. This is one of the main advantages as well, and it triggers automatically in a product, on a production of products with a better environmental profile, because in this way we can save CO2 emissions. At the same time, we can achieve and we can offer our customers virgin quality products. This is a 100% drop-in solution. In this case, in the case of this project, we can offer HIRSCH product with the same characteristics, with the same chemistry, and in this case, HIRSCH doesn't have to invest in new assets or in a new product development, or as Sven mentioned before, they don't need to start with new qualifications. As I mentioned before, one of the main advantages of this is the topic CO2 saving, yes, because we are replacing naphtha by pyrolysis oil, and it has a positive effect in the carbon footprint. We have prepared the first LCA studies focused on the Styropor P, and depending on the pyrolysis oil used, we can achieve CO2 savings which can vary between 55 and 95%. Another important question here is, as Sven also mentioned, for several applications, our customers and the customers of our customers, like eutecma, needs to work with products with highest standards in topics like hygiene or food contact. And with this approach, with the ChemCycling approach of BASF, we can achieve it.
Very interesting. Yeah, thanks, Jesus. So Alexander, we haven't talked about HIRSCH's perspective, the converter perspective. So what is your view and the advantages in particular on the project?
Yeah, thank you, Sven. Our view, or my personal view, being positioned and stationed in Austria, we here in Austria generally are world champions in recycling in general. So we're used to separate paper and metal and everything, and have a good recycling system in place in Austria, but it was very frustrating that we couldn't recycle EPS or styropor in the past. There was no possibility for real recycling. There was only downcycling possible with lightweight concrete and other good products, but it was not what we were looking for. And then when BASF came up and promoted or introduced Ccycled material to us, this for me was the door opener and the eye opener, that we all of a sudden have, from a molder's perspective, we have a material on hand which is easy to implement in all of our facilities. Like you mentioned before, it's a drop-in-place solution. eutecma, for example, is being served from several of our locations, so we can implement it very quickly, very fast in our production systems. There is no changes in our processes. There is no changes in the tools, which is important for the customer. So this was, like I said, the chance to go out to customers, and eutecma was the first customer that we approached on that possibility to use ChemCycling material, because they make premium products. They have a very high quality standard, and they have very high demand for good quality products, and therefore, it was a win-win, and at the end a win-win-win situation for the three of us to have the possibility to offer our end customers, the end consumers of the product, a sustainable solution, a solution which is moving our industry from a linear industry towards a circular economy or a circular industry. In regards to HIRSCH, we are, one of the larger players in the industry, and we want to contribute to our industry, number one, and we want also to contribute in general to the environment. And our focus is very strongly on recycling of or the use of recycled material. ChemCycling, like I said, is a super solution for that. We put photovoltaic systems on our facilities. We try to manage our resources. We try to reduce our energy consumptions. We try to switch to sustainable energy sources for our production. But that only together, every piece of the puzzle has to go together in order to make it circular. And the BASF Ccycled material was a key element, a key puzzle stone for this approach. And Thanks to eutecma, this was also the second major puzzle stone in this puzzle, because somebody has to build the bridge between the raw material suppliers and the manufacturers towards the end customer, the consumer, the market. And Sven Rölle has had several phone calls from me, long telephone conversations, where I was trying to explain what we can do with this key element and with this key puzzle stone. And I have to thank him for not dropping the telephone and to listen to me. And finally, we have been able to implement it. We see, all of us, the future in this material in general, in EPS as a strong material, even though it's very much under pressure from all sides, European Parliament and local governments and lots of, let's say, other possible materials. But in order to maintain our business and in order to contribute positively to the industry and to the environment, I think there is no way around recycling and closing the circle in the circular economy aspect. And therefore, again, Ccycled material, a perfect solution at the right time. And I think also the market is ready for it. A couple of years, nobody was talking about product carbon footprints and all these other things. Now it's a daily topic in our discussions with our clients. And therefore, it is, like I said, the right material at the right time with the right customer bringing it in the market. And also for the product, it's the right time, even though we all face a pandemic situation, which is not nice. But for this part of the business, I think even though it's bad, we can increase the use of EPS material, styropor material, and definitely we can increase the use of CCycle. So I hope I was answering all your questions in my enthusiastic answer now.
Anything to add, Sven, from your side, probably?
Yes, of course. So it's really, as Alex said, it's a fantastic material, absolutely. But yeah, for us, we are looking a little step ahead. Further, it's a big goal we are following with this is to implement real zero waste cycle, and therefore we are looking to close the loop completely. And actually, we are in the process of development a real circular economy with a pilot customer as well as with an international logistics service provider. And as I said here, the goal is that the used packaging can be returned. Then it'll be checked for reusability according to special criteria. And if it fulfills these criteria, it will be made available to the customer again, or if not, the criteria will not be fulfilled, then the material will be returned for 100% into a qualified recycling process, like CCycle, for example. And this is for us really a milestone on the way to bring a completely zero waste cycle to life. Absolutely, because also from my opinion, the EPS is not a problem material, then much more a valuable raw material, and this it has to become, and then we will close the loop.
Yeah, I think it's a good statement. I think we have to distinguish here or put the focus on two aspects that you have already mentioned, all three. So the one aspect, of course, the use of alternative feedstocks, like ChemCycled material, but you already described it. The end of life aspect is also really important. I think it's worth to talk about this, because we all know that styropor is a polymer which can be easily recycled and is recycled. So could you elaborate a little bit more on possible end of life options in mechanical recycling for the Pharmaboxes, for the pharma shippers?
Yeah, what we have worked out and what we have set up with eutecma, for example, is that clean EPS material which does not fulfill the reuse criteria, from eutecma, that this material will be collected by HIRSCH, and we will reprocess it in our own EPS recycling extruder, so means compacting the material to make it transportable, and then in a multi-stage extrusion process, we extrude the material and add pentane again, and we're able to produce 100% recycled EPS, which then can be implemented as new virgin raw material with an waste origin into our production facilities and into several products which we are already promoting strongly, and a few of them are already commercially live. The funny story about, or background story, was when Sven Röhle contacted us and said, okay, our boxes go around the world, what are we doing with end of life in other geographic regions where it's not so easy to collect the material and bring it back to Europe and bring it into CCycling or mechanical recycling. Also for that, we found solutions through the network that BASF has, through the network that HIRSCH has, through national and international EPS associations. So thanks also here on to the UMAP side and to the American Association. Through those links, where we have also found possible companies and partners which would take eutecma boxes when they end up in the US, when they end up in Asia someplace, and bring the material into the local EPS recycling stream, or into the local waste stream again. So even though the boxes are going out of our direct reach, we are able to make sure that the material is not lost, that the material is not going into landfill, is not degrading into microplastics and polluting water and soil. So I think that's a very, very important aspect, and the EPS industry in general is on the right track to move closer together to try to find creative solutions. Like I said, we do it in Europe with our locations. We have 28 currently. We collect EPS wastes, and we can reprocess it into our EPS material. And where we cannot, we have to find creative solutions to make sure that the material is recycled there as well.
Yeah, very interesting, and thanks, Alex. Sven, did you want to add anything?
As Alex already said, I guess it's absolutely important to close the loop completely, and therefore we are very happy that we have the partnership. We have the possibility to close that loop also, not just in Europe. So we are looking to have that partnership also as well in the US and other parts of the world, because what we don't want to see, absolutely not want to see, is that any EPS boxes are ending as a landfills or are swimming in the sea or somewhere else. And as I said, it is not. It is a good material, and it is a raw material. It is no waste in my eyes and from my perspective.
Maybe, yeah, one comment from my side. I think, and this is a really good example, no? If we want to achieve that plastics are becoming more and more circular, we need the willingness, we need the commitment of all the value chain. And this is a good example here. No? We need players who are willing to collect the material, who are willing to rework it, and who are willing to use it as a feedstock. And I would also add here that, and this is from my point of view, is important to remark. No? In the case of EPS, if this is a quite good material, had the proper properties to be mechanically recycled. If there is a possibility to collect this material, then you can use it in the proper way, because from a sustainability point of view, the better way or the better end of life is mechanical recycling. But this is not the case in all the applications. As I said before, there are still some applications where the packaging is disposed in the yellow bin or the yellow bag, for example. In this case, chemical recycling is the right end of life, because, like I said, if you don't have currently the way to sort it out, it can be the right end of life. But this is important, to remark, how these two different technologies can be complementary each other and can be the perfect solution as end of life for this material.
Yeah.
Yeah, Jesus, I totally agree with you. Just one sentence on that. I think the audience, for the audience, it's very important to understand it's not either or. It's not either CCycled or mechanical recycled. I think in order to close the loop in our industry, it is a complementary situation. Both of them need to work together side by side, and the value chain needs to work together from raw material through manufacturing, through companies that bring the product in the market and then trying to bring it back. So it's a joint effort, and there is no exclusion. For me, it's important for the audience to understand there is nothing is excluding the other. It has to be a joint effort from all sides in order to reach our recycling targets that we all committed to in the European community. Yeah.
Yeah, very good. Maybe Jesus, maybe you could give also a brief outlook concerning future prospects and the use of CCycled materials, because we all know that this is just one example, but we are also active in many other fields. Maybe you could give a brief overview on that as well.
Yes, I think, and we are fully convinced at BASF that the ChemCycling project can have a quite positive contribution in the circularity of plastics in general, but also for styropor. If we are, or what we are offering to our customers is this styropor produced from or based on recycled plastic, chemically recycled plastic waste. Therefore, especially for this application, for the packaging application, we are fully convinced that this approach fits quite well with the necessities or what our customers are looking for. In fact, we think or we intend that Styropor CcycleTM will be our standard grades for packaging in the midterm.
Very good. Yeah. Okay. Thank you very much for your interest in the topic, and with that we would like to close the webinar.